Okay, I think we got a good number to get started. So welcome everyone. Thank you so much for joining us for today's conversation on heavy duty transportation. We're so glad you're here. My name is Susie Spiegelman. I'm Director of Partnerships at Clean Energy Trust. For those of you who are new to CET, we invest in and support emerging climate technologies from across the Midwest region of the United States. Additionally, we host a variety of events and programming throughout the year meant to build the climate tech ecosystem, welcoming folks like you to learn about the industry, support our mission, and help scale emerging climate technologies. Before we get things started, we'd like to acknowledge everyone who supports our Clean Energy Trust. We're so grateful to all of our members and donors. They're the reason that we're here and why we are able to do the meaningful work that we do. If you aren't a member and would like to be, or if you just want to get involved with the work that we do, please reach out. Our marketing and communications manager, Amy, will drop our contact information in the chat for you to use at any time. So today's conversation will be led by CET's Managing Director, Ian Adams. He'll kick things off with a quick grounding on heavy duty transportation, followed by a group discussion with our panelists. At the end, I'll be back for audience Q&A, so as you think of questions during the session, please pop them into the Q&A window on your screen. And finally, at the end of the session, we'll be giving you some exclusive announcements, including a sneak peek of our next webinar coming up in September, so be sure to stick around for those details. So with all of that out of the way, let's turn things over to our speakers for introductions, and then Ian will take it from there. So John, do you want to kick us off with your introduction? And then we'll jump to Lee, and then Dale, and then Ian.
Sure. Thanks, Susie. Yeah, this is John Lovenberg, BNSF Railway, Environmental Vice President. So I lead all things environment and sustainability for BNSF. Who are we? We're a railroad. We're a wholly owned subsidiary of Berkshire Hathaway. We basically move the economy over 10 million units per year. We operate over 32,500 route miles in 28 states and 3 Canadian provinces. On the carbon front for this call, just table setter from me, we've committed to setting a science-based carbon target. We have a working goal, but it's not yet approved. Our general plan to achieve that is through operational efficiency, reducing our carbon intensity with renewable diesel. And over the long term, we just completed a battery electric locomotive test that I'll talk about. And we have tested a hydrogen battery electric locomotive in the past, so we may be doing more of that testing in the future as well. So look forward to participating in the panel and talking through some of the opportunities and challenges.
Great. Lee, you want to go next?
Sure. I'm Lee Kinberg, and I'm head of Environment and Sustainability for Maersk Line for North America. Maersk is a global ocean carrier and container logistics company operating in 130 countries. Our ocean division is the world's largest container shipping company. So a lot of those big blue ships that you see calling the ports are ours. We committed to net zero shipping by 2050. We have not yet set a science-based target. We are working with the Science-Based Target Initiative to establish the methodologies for the ocean shipping component of setting science-based targets. So once that's put together, then we will obviously be part of that. I think I'll leave some of the details of how we're going to do some of this for our later discussion. So let me just leave it there.
Great, thanks. How about you, Dale?
Thanks, Dale Smith. I'm a regional director in our environmental sustainability group at the enterprise level at the Boeing company. Really appreciate the opportunity to participate in Clean Energy Trust as a supporter, and then this opportunity today. Boeing company has been involved in the decarbonization conversation in commercial aviation for about 15 years. As a company, we accomplished our carbon neutrality last year through a significant number of traditional carbon offsets. We are very committed into renewable energy use in the company and a wide variety of other things. But what I want to talk about most today is our leadership position in working with the commercial aviation industry. I represent the company in the International Civil Aviation Organization's work on a long-term aspirational goal that's going on right now. But in 2016, the aviation community came together and made the commitment for a 50% reduction in our 2005 baseline of carbon emissions by 2050. We are in a thorough review of that. Again, we know that we want to go as far and as fast as we can. And there is a big focus, of course, on 2050. We have done some updates to the industry work and feel confident that it's achievable in the 2060, 2065 range, and just continue to review how we might be able to accelerate that. Significant portion of this for commercial aviation is going to be sustainable aviation fuels, which I'll talk about later.
Wonderful.
Great, Ian, the floor is yours.
Sounds good. Thanks, Susie. And thanks to everyone who's joined and to our esteemed panelists as well. My name is Ian Adams. I'm a managing director here at Clean Energy Trust, where I've been for the last 6 years or so. I'd love to just give a few opening comments and data points to sort of help set everyone in the same general state of place before we get into the discussion. So as we're talking about transportation emissions, you may be aware that transportation emissions are growing and they're the biggest source of emissions in the United States, around 29% or so. That said, most of these come from road-based vehicles, cars and trucks, which are a big challenge, but not the focus of this conversation. We'll talk about that at a future conversation. So of that, rail and aviation and marine make up a little less than 2 gigatons a year of emissions, or about 5% of global emissions. So that's the good news in the scheme of things. A relatively small slice. You probably see a lot in the sort of popular media about electrification. There's new electric vehicles. There's a lot of hype around that, and that's a popular solution and will be relevant for many sources of emissions, but will not prove to be practical for some heavy duty transportation applications. And so that sort of brings us to our challenges here. We're with all of these industries that have represented here today, they really need large amounts of dense energy that are required to move these planes, trains, and ships. And it'll be very difficult or impossible to completely electrify, and so difficult to decarbonize. And even when you look at analyses that are looking at a sustainable approach, looking at an analysis like consistent with Paris goals, the IEA projects there still be significant emissions associated with these sectors globally well into the future. Even if you look forward to 2050, while the IEA would be projecting that you need to get to about neutral from the power sector and from vehicles and all that, they still expect fuels with emission footprints to be used in aviation and marine and rail sectors at least through 2050, if not out to 2070 and beyond. So I think that underscores the fact that even in a sustainable path, these are very, very challenging solutions that people are pursuing here. And so we expect it to be a long and winding path. We'll surely need a variety of solutions. As John referred to it on our prep call, mom and apple pie efficiency, as well as low or zero carbon fuels like the sustainable aviation fuels that Dale mentioned, as well as innovative and new propulsion solutions. So we're here to talk about what these pathways and solutions are and how these leading companies are thinking about these challenges. So I'd actually like to start with a basics question. When it comes to the assets that you have in your fleet, how long is the useful life of these assets for commercial operations? The useful life of airplanes and locomotives and marine vessels, and how does that impact how you're planning for the future? Lee, could we start with you?
I'd like to jump in first because, as you know, we made the commitment to be net zero carbon by 2050. So the average lifetime of a vessel is 20 to 25 years. So if you do the math, that says this has to be the decade of action, that we need to be launching vessels during this decade. And about a month ago, or pardon me, back in February, we actually announced that instead of launching our first carbon neutral vessel in 2030, which had been our original plan, we were going to move that up to 2023, which our engineers has pointed out is 2 years. But we announced 2 weeks ago exactly what shipyard's going to build that ship, exactly what engines it's going to have, and how it's going to be fueled with biomethanol, bio or e-methanol. So it will be a renewable fuel based on bio pathways or e pathways.
Excellent. Thanks, Lee. Dale, would you care to jump in?
Sure. So as an OEM, of course, we don't operate much of the fleet, but we certainly pay very close attention to all of our customers and the challenge that they have and that we are all in to support. We have an all of the above approach. We have signed on with the rest of the industry for the most aggressive decarbonization process that we can work through. We do have extraordinarily unique physics requirements to fly the airplanes that we make. And those energy density requirements are the key challenge, no doubt about it. The all of the above approach for us is making sure that we continue to deliver the most fuel efficient airplanes we can to refresh the fleet. The global fleet has improved its fuel efficiency since the early 90s by about 1.5% a year, which is pretty extraordinary when you think of the size of the fleet and the number of airplanes. So we got to keep doing that. We want to keep working with our customers to be able to operate our airplanes as efficiently as possible, and we're engaged in a lot of technology and procedural dynamics to make that happen. There will be a need for some traditional offsets for a while in order to fully decarbonize. But the big issue is going to be the transition to renewable energies for the airplane operations. Hydrocarbons are going to be, hydrocarbon fuel is going to be and as drop-ins is going to be super important in this industry because these aircraft typically are going to need to be in the fleet for 20 to 30 years. So the airplanes that we've been putting in the fleet the last 10 to 20 are still going to be in for a bit. And of course, those that go in now. And we're working really hard on a number of pathways to deliver recycled CO2 through sustainable aviation fuels, and I can talk more about that in detail. But that really is our target for the next 20 to 30 years. Just low carbon, renewable and sustainable drop-in replacement hydrocarbon fuels are going to be the biggest piece of the pie. We are continuing to look at electrical options. We've been electrifying airplanes and increasing the importance of electricity on the airplane for a long time. That's one of the ways that we've been able to make them fuel efficient, so we can dedicate the fuel just to the propulsion of the airplane. So some hybrid electric, don't see a path for all electric for quite some time because of the weight issues. And then there are multiple paths with hydrogen that I can talk about later. But so we certainly are monitoring it all. First and foremost, we will always be talking about safety, and then the physics are really challenging. So, but we see a lot of potential, a lot of opportunity in the sustainable aviation fuel arena.
Fantastic. Thanks, Dale. And then, John, do you want to chime in on the sort of life of the capital assets and challenges
Sure.
that creates for you?
Yeah. So the short answer is about 40 years. A locomotive typically lasts 40 years, 30 years in long distance line haul, heavy duty service. And then the last 10 years, it'll typically get shifted over to regional or yard operations. And here's kind of an interesting fact for the audience. Not many people know this, but a standard locomotive is diesel electric. It's a diesel engine that makes electricity that runs 4 to 6 electric traction motors on each locomotive. So what we do is we use a remanufacturing model. Every 10 years, the engine gets remanufactured. It basically, you pull the engine out, you pull it apart, you put in new parts. It has lower emissions, it's more fuel efficient. So basically it's, you think of it as multiple lives of the locomotive. So the good news when it comes to new technologies, and I'll talk about this later on, is you can replace that engine with other means of propulsion if it's operationally effective and safe and cost effective. So I'll get into that in more detail later on, but that remanufacturing model and the fact that we already have electric motors on the locomotive is going to be a huge advantage that I'll talk about later.
Thanks, John. So you're not starting from square one there. Interesting.
Right.
It's interesting to see that all of us have started early and have been working on this efficiency, what you called motherhood and apple pie efficiency, the basic fundamental engineering over 10 years ago, and have been working on it probably longer than that. We've reduced the energy required to move one container 1 kilometer by 46% since 2008. That means we've cut the fuel consumed and the emissions that are derived from it by almost half in that 12-year period. So, and I heard each of you talk about some pretty significant improvements in efficiencies that have occurred over the last decade or two. So, I think there's reason for optimism in terms of getting where we're going to go, but you can't get all the way to zero with just efficiency. You've got to do something new.
Certainly. And I think that's a great point. On that note, when we're talking about something new, so obviously you've been doing a lot on the efficiency side and will continue to do that as it improves in operations and can improve your bottom line. When you're thinking about that new thing, do you expect that to be one technology solution? Lee, you mentioned biomethanol. Do you expect that to be the winner take all for the sector, or do you expect it to be different solutions for different applications?
Well, we think there'll be multiple winners and multiple pathways. The ocean shipping is not just one kind of vessel. You've got everything from fishing boats to cruise vessels to container vessels and many other applications. And what's best for each of those, a ferry might be easily electrifiable, but we're spending 2 weeks crossing the Pacific, not anywhere close to a convenience outlet. So we can't plug in and recharge. And of course, the bulk of those batteries, when you start talking those ranges, is prohibitive. The technology is at least an order of magnitude away from where it needs to be to make that kind of thing feasible for us and probably for the other two gentlemen on this call. So as you mentioned, the difficult to decarbonize. So the pathways will be different. We're focusing on 4 particular fuels. I can go ahead and reiterate those if I'm not jumping ahead here. We think, first of all, we're working with some biodiesel. So we offer a net zero carbon product today that's based on used cooking oil that we purchase, that's converted to a fuel and purchased in Rotterdam. And it's like buying green electricity. You can ship your containers between any 2 ports, and we'll calculate the amount of fuel that would take to ship. And then we buy that energy amount in biofuel. So it's a true reduction. It's not a purchased offset. It's an actual reduction within our operations. And that product is available to our customers today. It has started small, but it's really exceeded our expectations. And for the first time, we actually see customers willing to pay a premium to ship carbon neutral. And this is new just within the last 18 months, that we actually see customers willing to pay more to get that net zero property.
Interesting. And so that's the biodiesel, and then you
Yeah.
also mentioned
So then we've also got methanol and various other alcohols, which can be either bio-derived, or you can go the E route where you're using all renewables to make the molecules. Another one that we're looking at is some lignin fuels, where you actually take, say, one of those alcohols and you mix it with lignin, which is the second most common biopolymer in the world. So it comes from agricultural waste, it comes from forest products waste, and other things that today perhaps of low value in our society.
Like corn cobs, wood chips, that kind of thing.
Those kinds of things. And you mix those together, and it has not only some interesting technical properties, but it's also entirely bio-derived. So no new CO2 to the atmosphere. And therefore, and also because it's coming from those alternative materials, hopefully lower cost, because many of these new approaches are very expensive, anywhere from 2 to 4 times as expensive, even if you're just looking at some of the fuels. And then when you talk new technologies and new fuels infrastructure on the land side, you're looking at some pretty big investments. And then finally, long term, we're looking at ammonia as a long-term fuel, because it has, there is already an industrial infrastructure to produce and move and store ammonia. There are some toxicity challenges with that as a fuel, but it contains no carbon. So long-term, we're looking at that. Now we are following hydrogen, we are following fuel cells, we're following battery technology developments and those kinds of things. But those are the 4 fuels categories that we're really looking at. The biodiesel drop in today, methanol for the near future, lignin fuels out in the 5 to 10 year range, and then beyond that, looking at ammonia and other more creative solutions that might not occur to us today.
Interesting. And is that how you see it from that time frame, sort of like things?
Yeah,
that
we see it sort of phasing in. Yeah. But again, as I mentioned, we have to start this decade.
Absolutely. And thank you for laying that out. And for folks that hopped on the webinar that we discussed, sort of like the hydrogen economy, one of the reasons that some folks are interested in ammonia is that you can make it from hydrogen, or you could make it from green hydrogen if you wanted to long term. Dale, would you like to chime in? You know, it sounds like at least in the medium term, you expect sustainable aviation fuels to be sort of like the main winner in the aviation space.
No, that's fine. And even a little bit into what we might consider the long term as you get out towards 2050. I think love to hop in and follow on with Lee, because the storyboard is pretty much the same with a key caveat. So in understanding this industry, an integrated airplane is truly an integrated airplane. And so the engines that get designed and put on those airplanes are part of the overall aerodynamic structure of the airplane. We don't have the option to fundamentally change engines to swap them out for there are re-engineering processes that we go through, but that's a 15-year, 20-year kind of, or at least 10 to 15 from a derivative airplane. So what's so critical for us is finding these drop-in low-carbon solutions. Really maps somewhat similar to what Lee just talked about. We've got 7 pathways, approved pathways, that use biofeedstocks, again, agricultural waste and forestry waste. We're also leaning in heavily on waste gas. So any option for finding solutions for syngas that can be through technology from another of your sponsors, LanzaTech. Can turn that into ethanol, and we have a pathway for ethanol to jet. And landfill gases are in that category. There is some excitement around electrofuels or powered liquid fuels. That's the green hydrogen and direct air capture carbon kind of model. I want to point out there's green hydrogen applications across all of these sustainable aviation fuels because they're a hydrocarbon fuel. So any of the green hydrogen will help across all that. And of course, there's hydrogen fuel cells and hydrogen for direct combustion. But hydrogen as a component to a powered liquid fuel or electrofuel does have promise. What we're realizing for all of us that need to use fuels, so this of course would apply to marine as well, but many of these conversion processes, and in particular, powered liquids or electrofuels, the feedstock is renewable electricity. And it's large quantities of what will need to be relatively cheap and high volumes and super low carbon renewable energy. So a lot of the caveats you'll see out there in studies that talk about power liquids and electrofuels, you'll see we have a little bit of a mantra. We're like, yeah, we got to get the stuff that's in the asterisk out of the asterisk. And what we mean by that is the basic feedstock here is lots and lots more renewable energy, renewable electricity in order to do the electrolysis type process to get the green hydrogen in the first place, and also to run the technology that does the direct air capture to get the carbon out of the atmosphere. It's a great it's a great notion. The challenge is going to be just how big can we make and how clean can we make our electricity grids to be able to support those kinds of technology.
Yeah, I think that's a great point, Dale. A little bit off topic, but I was reading a report the other week that suggested that if you took the amount of hydrogen you needed, if you're going to make it green to make renewable plastics, you'd need as much power as it powers the continent of Europe. So the orders of magnitude that we're talking about, you're talking about a lot of cheap renewable energy for those electrofuels. A good point.
Yeah, you can get there in a hurry. I'll give you a quick example. We're based in the Washington area, of course, and the total energy quantities used right now from jet fuel for the airport at SeaTac, the fuel that gets loaded there. If you transitioned all that to a power liquid fuel, we'd have to use a third of all the electricity that's used in the state of Washington just to produce the fuel for SeaTac.
Thanks for that frame of reference. John, I'd love to give you a chance to chime in on, what do you think in terms of being winner take all versus a variety of solutions?
Yeah, so one or multiple winners in the rail industry. Let me give you an answer for 2020, 2030, and 2040. That's probably a good way to look at it. So today for, the mom and apple pie efficiency, I know we're sort of glossing over that, but all three of us are looking at energy management systems, network fluidity, idle control, right horsepower per ton, aerodynamics. That's the mom and apple pie. That's what's been going on now. The rail industry has doubled its efficiency using those measures over the last 40 years. So we can't just discount that there's not good value already being had in terms of that mom and apple pie piece. I would say over the next 10 years, we're very similar to what both Dale and Lee are talking about here on liquid fuels, which is a shift from fossil fuel diesel to renewable diesel. We don't have a cool branding name like sustainable aviation fuels, but maybe we should call it sustainable railroad fuels too. It's basically, reusing carbon that's in circulation and avoiding landfill gas generation to produce your carbon intensity. But beyond that, probably what's most interesting to your audience, not that renewable diesel is not great, because it's a big part of my job, focusing on increasing the percent blend and advocating for policies and other things you do to basically expand the use of renewable diesel. But what's next for us? We're testing a battery electric locomotive that we tested now. We can get into energy density issues. I'm happy to compare energy densities between liquid fuels and batteries. And because of that energy density challenge, the long-term answer may well be hydrogen. If we can't get enough ultimate energy density in a battery, then we may have to go to hydrogen for hydrogen fuel cells to make electricity that go into a battery that power those electric traction motors that I was talking about. So, where we might go in the future, is there something else out there, small scale nuclear or something else we're not thinking of? Maybe, but right now that's kind of the progression from, again, efficiency to liquid fuels to future propulsion.
Excellent, thanks, John. One other topic that came up in when we were discussing previously was, if you end up having different solutions, you end up having multiple sets of fuel supply and different sets of infrastructure that may be required. So, how big a challenge is that, or what are some of the implications of hopping for, or needing to incorporate multiple different solutions?
I would say, I would probably let Lee and Dale go first, only because you're in the middle of the ocean or you're in the middle of the air. So they probably have fewer options than locomotives. So let them go first, then I'll add some complaints.
I can jump in on that one. And you're of course, you're spot on. Sustainable aviation fuel is defined by three key areas of criteria. The first is that it does need to be made sustainably. So there, of course, we're talking about fresh water and land use and all the other things that lead up to doing things sustainably. The second key criteria, of course, is that it's going to deliver a much lower carbon footprint. And then the last, and all of these are equally important, but the last is the absolute must, is it has to perform exactly like fossil Jet A. It has to be a drop-in replacement. The investment in these aircraft and these engines, we certainly are looking at those other options down the road, but to move the size of the vehicle that we have, or that our customers get from us at those speeds, there's no margin for error. And so it basically the key criteria, so with these 7 pathways that have been approved and some are in use now, the key keeper in that is that the chemistry of this fuel has to be almost exactly, basically exactly. In some cases, it actually delivers a higher energy performance. So we're actually getting a little bit slightly higher energy performance out of some of the bio-based fuels. They're actually cleaner than the fossil fuels from an energy density perspective. But in some cases, so we've limited the blend ratios. So right now, a 50-50 blend is as far as we can go because of those safety concerns and because of the chemistry requirements. We made a commitment a couple of months ago that because we know in the 2035 to the 2040 range, the industry is going to need to be able to use 100% sustainable fuel in these airplanes. And that's about the time where we anticipate they might be commercially viable. So we made the commitment that by 2030, all of our airplanes will be certified to fly on 100% sustainable aviation fuel. And that we've got some challenges to work through there. Again, because they're cleaner, they do function slightly differently in terms of how they interact with materials in the airplane. But we can have lots of different pathways that get us to these drop-in fuels. But if you think about it, all of that infrastructure, as you pointed it out, to bring it to the airports, to store it, manage it, and bring it to the airports and fuel the airplanes. And it needs to be the same everywhere in the world because these assets are going to end up who knows where over their lifetime. So there could be a path down the road where there might be some electric and maybe some hydrogen, but again, the hydrocarbon fuels are going to need to be the dominant, and that's why we've got to have them be drop-in replacements. Thanks.
Thanks, Dale. Lee, would you like to chime in on that, sort of the fuel supply infrastructure implications?
Well, and let me point out that some of the most expensive rental property in the world is in our ports. And they are very, very heavily utilized, and there's no extra space just sitting around waiting for additional fuel depots of various types, liquefaction, whether they're storage or the various types of infrastructure required for these different types of fuels. Where are you going to put them, first of all? The next question is, where are you going to make them? You have to make them, and where are the raw materials going to come from? And Dale made a good point, I think it was Dale, about the land use changes. So what are the sustainable feedstocks? But we really believe that the biggest investment here is not actually on the vessels, but it's actually going to be on that landside infrastructure to actually make the new fuels, get them to the ports, and get them on the vessels.
Interesting. Thanks for that point. Now, I'd also like to touch on as we're sort of talking about the different angles here.
Ian, can I answer that question too?
Oh, I'm sorry. I thought I started with you. My apologies.
Well, I punted over to Lee and Dale only because. So let me at least hit the infrastructure. Obviously, if we're going to right now, we have a network of diesel fueling for our diesel electric locomotives. If we switch over to battery electric, we've got to set up charging infrastructure. And building on what Lee said, a big challenge is that the energy transfer rate, whether you're filling your tank or you're charging, we've got two challenges. Both the energy density per volume is a challenge, and the energy transfer rate are both roughly 2 orders of magnitude slower. Well, 2 orders of magnitude slower charging than filling up with fuels, and about 2 orders of magnitude more volume for the fuels. So those are huge challenges that we have to overcome. But for us, it's basically building not only a charging infrastructure in the same places that we have diesel, but because we don't have enough energy storage, we're gonna have to build more charging places along the way to be able to do opportunity charging as those locomotives are moving across the territories, the 32,500 route miles for us.
And John, I know in other parts of the world there's overhead lines that do charging. Obviously, that is a significant infrastructure build out. Do you expect that to be a significant piece, or not so much because in the United States because it doesn't exist much today?
You could do it where you have a dedicated route where you solely are moving yours. The challenge in the U.S. is we trade locomotives. We're moving locomotives and cars among the different railroads. So you basically have to have a uniform system where you're sharing locomotives across the system. If you've got a battery electric locomotive, it's a drop-in. It's basically operating with the right software across the locomotive consist, the 4 or 5 locomotives pulling a train, for example. So you basically solve the interoperability challenge with battery electric.
Excellent, thank you. One thing I wanted to just circle back to, Lee, you'd brought up the real estate rental property being very valuable at ports. I'm sure at airports it's not too much. It's not cheap either. Is there a silver lining there in terms of the concentration of locations as we start to roll out some of these new solutions? My intuition is that many long haul flights or ocean shipping go through a smaller number of locations, so that you wouldn't necessarily need to set up the infrastructure at 10,000 different spots. Or is that intuition not right?
Dale, do you want to jump into that one first, or?
Actually, can you take that one? Thank you. Follow up yours.
Okay, so
Sorry.
It seemed like you had a couple of different questions in that one. So could you perhaps just restate the question for us?
Oh yes, sorry.
Just briefly.
Absolutely. Does the fact that, or is the intuition correct that many, for long haul shipping, they're going to a relatively few number of ports, and so you could sort of do a hub and hubs of new fuels, new drop-in fuels, new infrastructure, as opposed to it needing to be in every port in the world? Or is that impractical when you actually get down to it?
And I'd have to say it is fairly impractical when you get right down to it. Initially during the first stages of a new fuel, you're probably going to have a low fuel corridor, a couple of selected ports that the vessels will move between, or the planes or the trains. But eventually you have to get to the point that things can move around, because that's the reality, is how it works. They get moved around.
Makes sense. Thank you, Lee. Dale, anything you want to add on that?
Yeah, I will. So I was going to make a comment after Lee's prior comments about the value of the land at ports, and of course airports included. There's a lot of those things that are challenging. And then we have, for better than a decade, been thinking about this, and increasingly in the last few years. So how do you turn that into an opportunity? And the opportunity for us in aviation is that we have when you really stop and think about the amount of the energy requirements in commercial aviation to move these amazing vehicles around the world, we have really a relatively very small number of filling stations called airports. And as a result, there's got to be an opportunity there. And we're starting to see that in the context of, while these fuels have to be drop-in and they have to be consistent for performance at any airport in the world, the feedstock pathway or the conversion pathway can certainly be different based on those regional opportunities. And so we've been doing road mapping. We would call them regional road maps, but to be honest with you, if you take some of the largest airports and you do regional road mapping for the types of sustainable aviation fuel feedstocks and conversion pathways, if you just think about it as concentric circles going out from an airport, you can really, I think, get creative about finding some unique solutions that would be that will be unique to different regions of the world, and unique to different airports in the U.S. as an example.
Interesting. So you have the same, Boeing jet refueling, in Brazil on one drop-in feedstock pathway, and in Mumbai on a different one, and London on a different one. But they're all the equivalent drop-in.
Yep. Yeah, the net result is they will all be Jet A equivalents and have the same basic chemistry in them. And to your point, for instance, an ethanol to jet pathway, might be more viable in Brazil versus a sustainable oil, pathway in the U.S.
Sure. And changing gears a little bit, obviously you're all under different regulatory and policy regimes. What policy challenges do you face as you think about adopting new solutions? John, we could start with you, perhaps. Oh, and I think you might.
Yeah, there we go. I'm back on there. I unmuted myself. I would say each of our industries are looking at renewable fuels, certainly. And today, renewable fuels are readily available in California. You have at the federal level, There are support system, the blender's tax credit, renewable fuel standards. In California, there's a low carbon fuel standard. There's a California cap and trade. When you start stacking those all on top of each other, right now, California is the destination market clearly for renewable fuels. That's where fuels from across the country really are going there preferentially. As Oregon, Washington, and other states add low carbon fuel standards, that's making renewable fuels more cost competitive. So I'd say on the policy front, when it comes to renewable fuels, in general, it's the, having policies that make renewable fuels cost competitive with traditional fossil fuels. On the battery electric side, the primary focus there is the economics, is making sure that electricity is cost competitive compared to fossil fuels. Today, almost everywhere, electricity is more expensive than fossil fuels. So that's a big challenge for those of us that are pushing the envelope on battery electric, whether it's battery electric in our intermodal hubs, yard trucks and cargo handling equipment, or whether it's locomotives. That is a key element as you're looking at the total life cycle cost. That policy issue of keeping electricity cheap to compete is a big policy issue. So those are the two buckets of policy that I would throw in the mix. I think one other thing I would add is incentives, grant incentives from at the federal level or the state level. That's been a key for us. The battery electric locomotive that we tested earlier this year was a joint project with the California Air Resources Board and manufacturers and other local agencies, as an example.
Thank you, John. Dale, do you want to chime in on that? Any policy challenges you face at Boeing?
Well, categorically, it really mirrors what John just said. So, and he's especially spot on in California. So there's a reason why currently the only commercial producer of sustainable aviation fuels in the U.S. is in the Los Angeles area, and all that fuel is being pointed towards LAX or any other California use because of the low carbon fuel standard and how significant it has created some price incentives in the market there. Jet fuel is uniquely regulated because, as you can imagine, it's quickly an interstate fuel, and then even as quickly globally, it's a fuel for international emissions, which there's no state that has jurisdiction over those emissions nor the fuel. So a lot of this we have done because it's the right thing to do, of course. But the net result is that we need market-based policies to drive the economics. And I guess the only caveat I'll offer to basically the same story that John just said is that this is now a renewable energy transition for all of our sectors, or for all of our portions of the long haul and heavy transportation sector. But if you stop and think about it, it's about where solar and wind were 20 years ago. We need the kind, and maybe even a little bit longer than that, we need the kind of public policy that recognizes that to do this, we're competing with fossil, and we need those kinds of tax credits and other meaningful incentives that don't have to be there forever, that can help close that price gap, like we did globally with solar and globally with wind energy. Get us to that 1-2%, maybe 3% of the market, and then it'll be able to settle itself in and be competitive on its own. But to get there, we really need that same kind of heavy lift that helps create those market incentives through market-driven policies. We don't see things like mandates being terribly effective. What's effective is delivering that the policies that can deliver the kind of economic incentives that are in fact working, like the low carbon fuel standard in California.
Excellent. Thank you, Dale. Lee, I'd love for you to chime in as well if you'd like. And then I'm going to ask each of the panelists what one thing they hope the audience takes away from this conversation before we move over to Q&A.
Well, and I have to build on something that Dale brought up, which is the international aspect of it, because the rules that our vessels operate under are set by the International Maritime Organization, or IMO, which is under the United Nations. But we are also starting to see some regions, most notably recently, the European Union, trying to set their own path because they feel that IMO is not moving fast enough. So we're very concerned that we'll see a regional balkanization fragmentation of the policies and regulations that are so necessary and need to be so consistent across the world. And then the question too is, incentives absolutely work, but how do you do that on an international scale? And how do we keep from competing with each other for the same feedstocks? You know, is there going to be a scramble for this particular drop-in fuel that then drives up costs and somehow creates an artificial market? So there's some real policy considerations here that we're all going to have to work through together, and it's going to be an interesting decade.
Thank you, Lee. Now I know I've seen a lot of questions come in across the transom or over the transom, but we'd love to give a chance to all of our panelists. Just quickly, you know, what's one thing you hope the audience takes away from this conversation? John, maybe we could start with you, and then Dale, and then Lee.
Sure. Part of our internal mantra that we have is if we just, for example, like our battery electric project, we don't want one cool demo. We don't want to high five and just say, hey, that was a great project. We made it operationally work and it was safe. Yes, it is. But the difference between one cool demonstration project and a full transformation and scaling is the economics have to work. And when you have these large scale, big investments, whether it's you know, a ship, an airplane, or a locomotive, you can't afford to get it wrong. So being able to basically build your total cost of ownership model and make the economics work is really where we're focused. So part of why we're optimistic on battery electric for regional locomotives and yard locomotives is the efficiency advantage. Battery electric is, again, 2 to 3 times more efficient than internal combustion electric. So we can use, you know, a third to half the energy. So that's the key driver for the economics, is bridging the gap on the early entrance, because you've got high cost before you get manufacturing scale, keeping electricity prices down, and then taking advantage of those efficiency advantage of the means of propulsion that you pick. There's a lot that goes into it. There's partnerships, there's agency engagements, there's emissions, but those are, you know, taking that systemic approach and really trying to make the economics work as to how to get scale.
Thank you, John. Dale, what's one thing you hope folks take away from this conversation?
That the physics of flight and the nature of our vehicles as assets and the duration that, you know, they're going to be needed to recoup the economic value means that we really have to solve this in the near to even mid and almost long term through a hydrocarbon fuel that has that kind of energy density that can make this work. And the corollary to that is we're well down the road on it, and there is a lot of hope that we're going to figure this out and be able to do this through some sustainable aviation fuels.
Excellent, thank you, Dale. And Lee.
So my turn. So we've talked physics and we've talked economics, and both are absolutely fundamental to making this happen. So let me talk a little more about the process. When we made our commitment to net zero carbon shipping by 2050, back in December 2018, we really did not know how we were going to get there. And we actually went out to the innovation marketplace and said, we don't know how to do this, work with us on it, and set up structures to start making that happen. 2 years later, we announced that first carbon neutral vessel. Now, it may not be the ultimate answer, but we think we see pathways that will work. And so I guess my message would be one of the need to work with innovators, which I guess brings you right back to the purpose of the Clean Energy Trust, and the need to work together as industry and as fuel consumers, but that we can do this. And we have to do this because we're a pretty significant portion of the total anthropomorphic CO2 and greenhouse gases that are generated, and that is not sustainable. So we have to make this work.
Excellent. Thank you, Lee. I think you said, it's going to be a very interesting decade. And I know it's been an interesting hour for me as well, hearing from all of your perspectives. So thank you so much for joining us. I'm going to turn things over to Susie, who is going to lead us through the audience Q&A.
All right. Thanks, Ian. We had lot of questions come through over the past 45, 50 minutes. So we're going to try to get to as many as we can. But the first one I want to start off with kind of leaves off where Lee was just talking about. You were talking about when you first decided to go after these decarbonization goals, you went out to the innovation marketplace, which I imagine brought on a lot of collaboration opportunities. So the question for all of you, and maybe Lee, you can share a little bit more first, what sort of collaboration is going on as you're trying to achieve these hefty goals? Are you working with competitors, clients, vendors, laboratories? What's the creative and collaborative process to get you to where you need to go?
Well, shall I jump into that first, since
Sure.
I kind of threw that out there?
Yeah.
We are working with universities. We are working with some of the national labs, or trying to talk to them and work with them. We've been part of the Clean Cargo Working Group for many years, working closely with customers who are very concerned about this. Almost half of our top 200 customers have set zero-based goals or are in the process of doing so. And our scope 1 is their scope 3 for transportation. So for them to reduce their scope 3 transportation emissions, we, all three of us, have to reduce our scope 1 emissions. So customers have actually stepped up and said, we will work with you with that university to develop, for example, the lignin fuel that I talked about. We've had actually financial support as well as technical and intellectual support from several customers in actually getting that process accelerated. And that demand signal from customers really gets board attention, and it really energizes a whole project.
Great. I imagine that John and Dale have had similar experiences. John, you want to tell us about your collaboration efforts?
Yeah, let me start with the obvious, which is probably a similar story, I think, to what Lee said, and what Dale would probably say is, well, Dale is a manufacturer, but we've been working with the large manufacturers in the locomotive space. I've talked about working with different agencies on grants in terms of supporting some of the R&D, working with our associations on developing common standards for things like standardized charging, working with universities and some of the innovation. The part that's maybe surprising is we've been contacted by the mining industry. The mining industry, in some cases, owns their own integrated mines, railroads, and port facilities. And they've been making commitments to zero emissions. And the size, the locomotives, and some of the size of the trucks, for example, mine trucks that have been electrified are very similar size to locomotives. Underground mine trucks are way ahead of us. So the same manufacturers are basically taking the know-how from the mining industry and applying it to a 4,400 horsepower locomotive. So that's maybe the only surprise in terms of collaboration, is being open and listening and finding who has common challenges you could really accelerate. The mining industry is calling this pre-competitive collaboration. We know that we've got these aggressive climate goals, and being able to leverage that know-how, you could really accelerate things much more quickly when you do that in early collaboration. And then there may be some breakaways in terms of being first movers, but there's also value in leveraging those other industries. So that's maybe from a collaboration standpoint, the one aha moment that I have from the last couple of years.
That's really interesting, because mining kind of tends to be out of sight, out of mind. But when you think about the magnitude of their fleets, just the sheer size of the trucks that they're using, it truly is heavy duty transportation. And it's interesting that they're starting to think about that from a decarbonization perspective.
Yeah.
Dale, what about you? What sort of collaboration are you doing?
Yeah, so I'll just set the stage by saying I don't know that there's an industry that needs to be, has to be, and has been more collaborative, because all commercial airplanes have to operate in and out of the same airports with the same, and be able to operate with the same air traffic management systems, the infrastructure at the airports, et cetera, et cetera. And when it comes to this fuel exercise, this is an industry issue. This isn't just ours, and it's not just any one of our customers. So we're all in on this as an industry, and we end up finding ourselves in conversations and in places where we normally might be taking a more competitive approach to say, let's let's all jump into this together. And it has been that way from the beginning on the sustainable aviation fuels front. So we are all finding opportunities for unique places where we can step in to invest and find some of those specific technology pathways. We made an announcement last week that we're doing an investment, as an example, in a sustainable aviation fuel production facility that's being planned in the West to support the airports on the West Coast. That is unique through a group called Sky Energy. It's a unique pathway, and it's one that has not yet been commercialized, but has a lot of promise. And Airbus and everybody else across the industry is doing the same kind of thing. There are those regional opportunities for those collaborations. You know, the Europeans are going all in on some green hydrogen things in a little bit of a different way than maybe elsewhere in the world, and that's a place where we want to collaborate, but we're also looking for places where we can do things that are unique to where maybe our customers are where we're actually located. So, and it cuts across all the research institutions with the FAA and NASA and their equivalents around the world. And we do a lot of work with the universities as well. An example, the University of Dayton has really the gold standard for fuel testing for the ASTM standards, and that's been a long partnership that we're a part of there.
It sounds like it's just a huge effort, and hopefully a lot of good things to come over the next several years, which brings just a follow-up question to that. You mentioned your 2030 sustainable aviation fuel goal, getting 100% sustainable aviation fuel in an aircraft. What goes into making that happen? How are you going to make sure that you hit that goal by 2030?
Yeah, so it's a tough one to go to make sure that we're clarifying here. So the fuel industry is going to determine the path to getting those 100% fuels commercially viable. Our commitment is to making sure that our airplanes can use those fuels.
Got it.
So we're working with the fuel companies and then our internal propulsion systems folks and fuel system folks to say, let's go test this stuff out. At that level, we're going to have to do this in a really meaningful but as scaled way, because you don't go test this out on a commercial airplane that's out there operating, of course, and then find out what it is that needs to be adjusted. Some of that adjustment may be to the fuel, and then some of it may be to the materials in the airplane. So, and all those things just take time and effort.
Yeah. Well, speaking of time and efforts, for John, for locomotives and ships, when you're thinking about electrification, one question that came through was, do you see battery swapping as a viable alternative to charging? Would that be possible, to set up along railways?
Yeah, the mining industry is basically doing that at underground mines. They're dropping a battery pack and picking up another one. For us, Vale Mining in Brazil is looking at battery tender cars. So rather than physically removing it, you just have a rail car that is filled with batteries with electrical connections that pulls up behind. So if you think about the old coal cars where you're pulling the coal, it's the same thing. You're pulling batteries. So if we can't get energy density, that's the one thing. Now it takes extra energy to move the batteries itself. So you're going to have some lost efficiency, but that certainly is a concept to try and get more batteries in the locomotive, in the train.
Very interesting. And last question for Lee, along a similar note, has there been any thought given to refueling terminals offshore to help alleviate some of the premiums that you're seeing for land rentals along the coasts?
I think we'll see all sorts of innovative solutions along those lines, and perhaps offshore electrical connections for vessels that are at long-term anchorage, those kinds of things. I've not been that involved in those concepts because right now we've got to figure out which of these solutions are going to be occurring at what time frame.
Mm-hmm. Great. Okay. Well, unfortunately, we are just out of time. We have plenty of questions that could keep us going probably for another hour, but in the spirit of keeping everyone's days on schedules, we'll stop here. We hope that everybody enjoyed this afternoon's conversation. In the next couple of weeks, we'll be announcing our next chat, which will be in early September. It will be focused on diversity, equity, and inclusion in climate tech. You won't want to miss that one. And if you are a startup here who's listening in, Amy mentioned in the chat a little while ago that our investment cycle is currently open. position. We're looking for applicants. So if you're a startup and you're listening, please do apply by Monday. We'd love to take a look at your applications. So with that, we'll close out by thanking our speakers, John, Lee, and Dale. It was a pleasure chatting with you this afternoon and hearing your expertise. Thank you so much for your time, and thank you to everybody who joined us today. We hope that you all have a great afternoon, and we'll see you again soon.